I'm Joseph Poon. This is Taj. We're doing.
They heard us. Yeah, it's okay.
Yeah,
okay.
we're doing a
Lightning
presentation on Lightning Network.
Micropayments.
Yeah, Bitcoins.
Okay.
So right now, Bitcoin faces some interesting memes, right? Like transactions aren't instant. Micropayments don't work, and they really don't work, right? Transaction fees on the order of tenth of a cent to several cents, depending on the exchange rate. And Bitcoin doesn't scale, right? Especially if a lot of micropayments. It sort of doesn't work, right? 1 megabyte blocks, well, let's increase them, right? Well, what happens when you increase them, right? You go from 7 transactions per second, 1 megabyte, with about 220 million a year, with a 7 billion, give or take, population of the world. That's less than 1 per year, substantially less. So what does Bitcoin look like with 1 billion transactions per day? There's 1.6 gigabyte blocks, 87 terabytes per year. You have enough for maybe San Francisco. Well, you might be like, OK, well, let's just up it even more. Then what happens? Then you have some centralization, right? Mining sort of doesn't work. You're just going to have maybe 1 pool or 2 pools, and they sort of have an incentive to make bigger and bigger blocks, and it creates more and more centralization. And an individual running Bitcoin at home cannot do a full validation of Bitcoin. So it's not really Bitcoin. It's not really decentralized, and it doesn't really work that well. So how do we solve that, right? You could dump everything into a SQL database, give everyone your money. Coinbase does that. But it's very useful. There's sometimes a need for that. You can put everything into sidechains. You can also use payment channels, which is a one-to-one connection between another party. So it's sort of like the Starbucks gift card model, where you always have a single relationship with another entity. These do face some problems. The SQL database model is also implemented as Mt. Gox redeemable codes. So when you give custodial risk to someone, that creates problems. With sidechains, it's a little bit more tricky. It's not primarily a scalability solution. It works really, really cool with things like Namecoins. You kind of want Namecoins to use Bitcoins instead of having their own currency, and it's a really, really promising technology. But sending funds between chains may exacerbate the problem if you want to send funds between them, because it's sort of 2 transactions instead of 1 now. So for example, there's Bitcoin, there's chain A, chain B. If you have money on chain A and someone else wants to receive money on chain B, you sort of need to bridge them, and that may create 2 transactions instead of 1. And with payment channels, if you have some recurring billing, that works. But what if you want to spend someone else? Then you have to make a Bitcoin transaction. What you really want are anyone-to-anyone payments. And that works in Bitcoin, right? When it hits the blockchain, anyone can send to anyone else because you can just set the output to any address. In the SQL database model, where you just give them all your money and then they just update entries in some database, you sort of need to give that one person your money. So for example, if you had someone that wanted to receive money in Coinbase, you can send them a Bitcoin transaction, but that's not scalable, so you've got to put all your money in Coinbase and send it to all the other people inside this Coinbase network. So that creates a lot of centralization. For sidechains, you need to be on the same sidechain, or else you'll have that doubling of transactions. Inside a payment channel, you just need the same relationship. So what we propose is having a payment channel between many parties in a multi-hop hub and spoke, which is conceptually similar to internet routing. And this uses minimally trusted intermediaries in that they cannot take your coins. It does not involve a third-party custodian. but it does require a small malleability soft fork. And there have been soft forks in the past, pay to script hash, BIP34 with the Coinbase transactions. And we kind of need to fix malleability anyway. If we fix malleability, we can do this. Taj will go into payment channels.
Okay, so I'll introduce the sort of basic payment channels, and we'll build off of that. So we actually were sort of looking like who came up with the idea of payment channels. It's not a new idea. I can find stuff from like Mike Hearn and some other people like 2012, but I don't know exactly who came up with it in the beginning. We may never know, but it's an old idea. Well, old for Bitcoin. It uses multi-sig, and it allows two people or two entities to send transactions to each other rapidly without hitting the blockchain every time. Okay, so I'm going to go through the basics of how to create this is a two-party payment channel that's unidirectional. So Alice can only send money to Bob through this. So what she does is she doesn't send yet. First she gets a refund before actually committing. There's a multi-sig address with Alice and Bob who both have control over this address. And Alice wants to send 1 Bitcoin to it. Before she does so, she gets Bob's refund signature. So that at worst, Alice loses her coin for 30 days. So Bob essentially creates this 30-day end lock time refund signature, signs it, sends it to Alice. Alice can either sign it herself and keep it that way, or just wait where it's half signed and sign it later. But Alice keeps this red dotted line on her hard drive because she knows, like, okay, at the end of the month, I can get my money back. Worst thing that happens. And then once she has this, she knows it's safe. She sends the Bitcoin from her just single user address to the Alice and Bob multi-sig address. Okay. Then, once it's in this multi-sig address, she can commit to payments to Bob. With no lock time, Alice alone signs and hands this transaction to Bob, all out of band. So Alice says, okay, there's 1 Bitcoin in here. I'm going to give 0.9 of it to me and 0.1 of it to you, Bob. And here's the transaction. I'll sign it and send it to you. It's not a valid transaction, right? Because Bob has not yet signed it. So Alice cannot push this to the blockchain. All the miners, every node would ignore it and disconnect. But she can give it to Bob out of band, some other network, and say, here, Bob. And Bob can treat this as a payment, right? Because this is worth 0.1 Bitcoins. Bob can now sign this at any time, right? Signed by Alice, signed by Bob, and broadcast to the network. And in so doing, close out the channel. But Bob does not sign and close out the channel. Bob waits because he knows this channel is going to be open for the rest of the month. So Bob waits, and then Alice pays him again. Alice says, okay, I'll give 0.8 to me, 0.2 to you, and I'll sign it, hand this transaction and signature to Bob, and Bob essentially overwrites this old one because this is purely better for Bob than the bottom one, right? This is better. Bob gets 0.2. That's better than 0.1. He can keep it on his hard drive if he wants, but he's never going to broadcast it. He's not going to sign it. This is better. And he can keep doing that, right? So, and then at some point, Bob says, okay, the channel's over. Either Alice can request the channel to be closed out, and Bob can cooperate, or if Bob's a jerk, he can wait until the end of the month and then keep Alice's funds locked up for the whole month and then sign. If Bob waits too long, Alice gets all her money back. So Bob is pretty motivated to sign this at some point in the next month. When Bob signs it, okay, it's signed by both parties. There's no end lock time. It goes to the network. And all the network sees is 1 Bitcoin from Alice to multisig, and from that multisig to these 2 addresses. So during that month period, Alice can send as many small microtransactions to Bob as she wants. Okay, that's the unidirectional channel. Is everyone mostly on board with that? So you can actually change the direction of channels after you've created them. The startup is the exact same. You get a refund from Bob to Alice, signed by Bob. Alice keeps that. Alice pushes the 1 Bitcoin into the multisig address. But now when Alice spends to Bob, she does so with a 29-day lock time. So if this refund is valid on the 30th, this spend to Bob is valid on the 29th. And she can start incrementing it the same way, keeping the same lock time. now Bob has 0.2. Do we stay at point? Yeah, Bob has 0.2, and Bob wants to pay Alice back. For whatever reason you want to, Bob says, okay, I'm going to pay you now from the money that you were paying me. And he can, sort of provably commit to a payment to Alice by overwriting this back to the 0.1, 0.9 version. Now it's a 28, so Bob signs it with a 28-day lock time, sends that signature and transaction to Alice. Alice can now broadcast this before Bob can broadcast this. So Bob, isn't getting the 0.2. Bob's getting 0.1 because Alice broadcasts first. So you can change the direction of the channel a number of times, but each time you change the direction, you have to bring the lock time closer to the present. So you can't keep doing it a million times, right? You're going to probably want here we have a day difference. That's probably excessive, but you want a decent amount of slack in between those two times, so there's not really a race condition. And you can start bringing the lock time closer to the present, changing direction. And to close the bidirectional channel, both sign. They can both sign a new thing with no lock time if they cooperate, or they can sign the lock time one. Okay, so then I will transition briefly to three-party payments. I'll show the motivation, and Joseph will say how it actually works. So what would be really cool is, let's say Bob is a big company, or they're some kind of payment processor. There's some kind of company that a lot of people are paying. Coinbase, BitPay, Newegg, I don't know. Something people use a lot. And Alice has an existing channel open. Carol has an existing channel open. Everyone's got a connection to Bob. Alice, though, wants to pay Carol. And Alice could just send the Bitcoin to Carol, but this is in the future where everyone's using Bitcoin and transactions are kind of expensive. So Alice wants to save money. And since these channels are open, it would be really nice if she could send it to Bob, who then sends it to Carol. That way nothing has to touch the blockchain, and it's free. There's no transaction fee. So Alice can send 0.01 Bitcoins to Bob, and then Bob can send the 0.01 Bitcoins to Carol. So this is a micropayment network. There's some trust issues here. Bob might just keep the 0.01 Bitcoin, and he can say, I'll keep this. You also have the problem that Carol can claim she never got the coins, and there's no real way to verify that the payment. Carol's like, no, I got this from, Carol can get 0.01 via Bob, but Carol's like, no, that was from Dave. So this doesn't really work. I mean, it might work if you trust Bob, but we're trying to get away from the whole trust thing and eliminate that and minimize it to the extent possible. Okay, so Joseph will talk about how to actually do this.
Yeah, I mean, that model works pretty well in the meantime, though. I think you can mitigate it in other ways using, 2 of 3 multi-sig, whatever. There could be elaborate things you could do, but it'd be nice to do this in a trustless way. So what can you do? You can create a hash lock contract. Now, hash function is a unidirectional cryptographic method whereby you take some input and you get some output that cannot be reversed. So, what you do is you take some random data R, and you convert it. You run it through a hash, let's say hash 160 in Bitcoin or whatever, and you use that as sort of a key, and you need the lock, which is the random data R, in order to unlock the funds encumbered. And there's a paper in, I believe, 2013 called Pay to Contract. And essentially, if Alice has the data R, which produces H, she can say, I have paid you the money, right? And she does that by the receiver writing some signed message, effectively a contract, that says, if Alice knows R, which produces H, then at that point, Alice has paid me 0.1 Bitcoin. And that works. And you might ask yourself, well, why don't you just check on the blockchain? But you can't, right? Because everything we're discussing here, nearly everything, is off blockchain. So you need some way to prove that funds have been sent. So essentially, This right here is what Carol produces. Carol has some random data R. She runs it through a hash function, let's say the Bitcoin hash 160 or whatever, to produce H. She gives H to Alice, and now Alice knows H, but she doesn't know R, right? And Carol has both. Alice uses a payment channel payment to Bob, but this is encumbered and can only be released if Bob can produce R. Okay?
Different preimage, but
Yeah.
yeah. Assume the hash function works.
Yeah. Yeah, let's assume it all works. I mean, you know, if it doesn't work, Bitcoin has some problems. Yeah. Bob does the same with Carol. So what happens is Carol has a payment from Bob that is encumbered, and Carol can only pull funds if she gives Bob R or broadcasts R onto the blockchain, right? So what happens is Carol says, I want my money. So she tells Bob R. And Bob and Carol can broadcast the channel onto the blockchain, or they can just agree to novate and say, OK, we're good. I know you know R, you gave me R, I know you can pull the funds on the blockchain. Let's not pull the funds on the blockchain because that's expensive. Let's just do this inside the channel. And they both agree to do that. If Bob is uncooperative, if Bob is uncooperative, then Carol does broadcast it onto the blockchain. But Bob is nice today. So Bob, now that he knows R, can pull the 1 bit cent from Alice. So Bob, acting as the intermediary right there, is not really in substantial risk if you look at it this way, right? He can always pull funds from Alice and give it to Carol, right? Possibly. Problem. If Carol refuses to disclose R, she can hold up that funds in the channel, right? Even worse is if Alice's connection with Bob expires before Bob and Carol's, then Bob sort of has already paid Carol, and Alice's and Bob's channel is closed. It's hit the blockchain, right? So Bob can be out of money. That's a problem. The other problem is that Bob sort of has to be really rich, right? And this is sort of unintuitive, but think about it this way. If Alice and Bob have a channel, and Alice committed 1 Bitcoin, so the ledger is Alice has 1 Bitcoin, the channel is 1 Bitcoin, Bob is 0 Bitcoin, then, OK, that means that Alice can only send funds. Alice can't receive any more funds because she's sort of full. If everyone gives money to Bob, everyone has full funds. You kind of want Bob to send money out, create channels outside, right, to other people. So for example, if Bob sends funds to Alice, then that has a channel that can be spent. So then the system sort of works. The availability of funds that Bob has some implications for fees, but we won't really get into that. It's just Bob just needs to be really rich on a single hub and spoke model. So let's say Bob is rich. How do you mitigate this problem? You can do things like third-party multi-sig, where Alice and Bob, this payout also has some third-party escrow service or something like that. That can work today, and I think it could work fairly well today. You could also trust that Bob will be honest and send the money and not encumber everything. That works too. But what we really need is to build a trustless model, right? Corruptible custodians are undesirable. You kind of want Bob unable to steal funds. But right now with Bitcoin, complex chain transactions don't really work. With malleability, you can create these hostage scenarios. So if funds are locked into a 2 of 2 multi-sig and the transaction gets mutated, the refund transaction is not spendable. And with 2 of 2 multi-sig, one of the parties can just resign, right? You can't really protect against that well, especially if the transactions are chained, right? Like 2 or 3 deep. Like a transaction is spending to another transaction So in order to do that, we need to fix malleability, and Tad shall go into that.
I had a talk about this a month and a half ago or so, and this is another use case where you basically need some kind of SIG hash modification. You could do a totally different signature with a different opcode, or you can just have the SIG hash flags, and you could have a SIG hash normalized, which uses the normalized TXID, which is just the same calculation as TXID, which with the signatures stripped out from the inputs, or a SIG hash no TXID input, where you remove your input TXIDs completely and essentially have malleability on your input side as well as your output side, which is slightly more risky if you are spending to the same address multiple times, but you shouldn't be doing that anyway. So both of these are, the no TXID, the no input is a lot more flexible in what it can do, but you SIG hash with a normalized TXID also lets a lot of these contracts work. So hopefully we can get both of these SIG hash types or something equivalent in functionality into Bitcoin pretty soon. I don't think there's a ton of controversy because, you have stuff like SIG hash none, so why not have these, right? It's much safer. And then, I guess there's a link to the paper I talked about a few weeks ago. Okay. You can
Okay. So in order to enforce Bob being able to send to Carol and Bob knowing he can receive funds from Alice, you kind of want to build this contract, right? And what would be the terms of this contract? I think, for example, a contract can look like if Bob can produce to Alice some input R, and R being some random data that Carol generates, or Bob generates, rather. With input R from hash H within 3 days, Alice will pay Bob 0.01 Bitcoin. However, after 3 days, the above clause is invalid. Meaning, within these 3 days, if you can produce this hash, you will get 0.01 Bitcoin. But after 3 days, the funds locked inside this output will be refunded. And either party may agree to settle the terms using other methods. So for example, instead of broadcasting on the blockchain, they can agree to settle it out inside the channel. And violating the terms will incur a maximum penalty. So for example, if Bob tries to do something sneaky after 3 days, you kind of want Bob to make sure you won't do something like that. So you create a contract inside Bitcoin scripting itself using multiple transaction outputs. So there's a single output of 0.01 Bitcoin between Alice and Bob. And the payment, which is this is sort of point number 1. So the payment has no lock time, but requires R. So if this output committed between Alice and Bob produces R, he can broadcast on the blockchain a transaction that spends from this output. And Bob would have to broadcast both the output and the spend. However, after 3 days, Alice has an unencumbered transaction which does not require R, which is a refund of what Alice committed, this 0.01. So what happens is Alice funds the 0.01. Bob doesn't broadcast anything. Alice can broadcast a transaction that gets some money back. If Bob produces something within 3 days, he can get 0.01 Bitcoin. And this is sort of what the script looks like for the output. Spending that is pretty simple. You provide the data, either or. The first one has 3 items. The second one has 2 items. So what happens is when 3 days occurs and Bob doesn't produce anything, Alice has the option of going to Bob and say, hey, you didn't produce anything. Let's update the channel to remove this output entirely. And Bob can agree, and that'd be good. If Bob doesn't agree, Alice broadcasts the output and the refund onto the blockchain, right? So what can you really do? Let's say Alice wants to send funds to Dave via Bob and Carol. And Alice discovers Dave through something like BGP or CJBDNS or whatever. But she knows that there is some network that Bob and Carol is in. So maybe there's like hundreds of Bob and Carols, right?
You got Visa, MasterCard, Amex,
Yeah.
Union Pay. Yeah.
There's a fair amount, right? Maybe more than today with card processors, but there is some route, right? And the blue lines are individual channels between the participants. This will start looking like what it did before. Dave generates an R. She gives H to Alice. Alice creates this contract output. So instead of a standard output, she creates this contract between her and Bob, right? It's a hashed, time-locked contract with a 3-day lock time. So the funds are locked up for 3 days, and if Bob can produce R within these 3 days, then he can pull 1 bit cent from Alice. But if he can't, Alice sort of gets her money back. Bob does the same with Carol, except this time it's 2 days. And Carol does the same with Dave, except this time it's 1 day, right? And at this point, Dave can pull money from Carol because Dave knows R, and it's encumbered with knowing R. So Dave pulls R. Dave pulls the money using R, and Dave could broadcast it on the blockchain, and Carol could broadcast it on blockchain, but they agreed to just remove the contract from the channel and just send the funds atomically, right? Bob does the same with Carol. Alice does the same with Bob. And at this point, Alice has sent funds to Dave, and no transaction has hit the blockchain, right? None, nothing. What happens if Bob just decides not to cooperate with Carol on day 2, right? So it's right here. And instead of doing this, Bob just says, I'm not going to talk to you, Carol, and just ignores him, right? Carol, knowing R, broadcasts the entire transaction chain onto the Bitcoin blockchain, right? So what happens is the blockchain now knows R because Alice has redeemed the funds. And at this point, Bob has sent money to Carol on the blockchain. And
Unwillingly, yeah.
Unwillingly, yeah. There's no cooperation. Carol can unilaterally take the money.
And reveals R, so Bob can now get his money, even
Yeah,
though he sort of
so-
doesn't deserve it.
Yeah. Bob doesn't deserve his money. He looks on the blockchain and goes, hey, I see this R. I'm going to take my money. But if Bob's not paying attention, then Alice, after 3 days, can just say, I want my money back. And Alice sort of gets it for free, right? Alice, knowing R in the contract, she technically has paid Dave. Which is why you generally want to broadcast, agree, and be cooperative. So what does a timeout look like? Let's say Dave never broadcasts R. Dave just says, I'm going to sit on this and ignore everyone. Then what happens is that Dave's and Carol's channel, the output, closes first. And Carol is happy with this setup because she knows that her payment closes out, and the knowledge that she will close it out before her money gets pulled. So the nice thing about this is that if Dave discloses R after the fact, Carol has already closed out her channel. She doesn't care, whether it be inside the channel or on the blockchain. She doesn't care. And right now, like, it closes out, and it's okay, right? And it's as if the transaction has never happened after 3 days. So what are the implications of this? You can sort of view Bitcoin transactions as circuits instead of packets. And only uncooperative channels get broadcasts on the blockchain, other than expiring, of course. But that means that you really have to look at Bitcoin a little bit differently. If most of the transactions occur off-chain, then Bitcoin's view as a circuit, there's a lot of changes. I don't know. Like, I won't go on a long rant about that. But in any case, nearly all transactions do occur off-chain securely, and there's near zero risk. The risks primarily relate to not broadcasting in time, and there's
race conditions.
There's
kind of
ways to mitigate that. It's in the paper. But effectively, if everyone broadcasts everything on time, then there's no situation where Carol has already paid Dave, but can't pull funds from Bob, right? So it's pretty much near zero trust. It's very different than giving custody of your funds to a third party. And creating channels will become very, very infrequent, I think, if you use something like this. So then a question would be, well, these channels are operating between Alice and Bob. They'll eventually expire, right? And then you make a new channel, and that's like, well, that's sort of a lot of blockchain spam. Because you have this trade-off between channel expiry and
time risk.
Time risk, right? Time value of money, fundamentally. You can mitigate that with another soft fork using relative check lock time verify, whereby the transactions, the transaction outputs have a relative time lock dependent upon when it enters the blockchain, instead of some hard block height. And if you want more information, check out the paper. It's sort of a long way to explain it. And I don't know if it will ever go into Bitcoin, but if it does, it'd be nice, because you can have transactions, channels, rather, that span for years and just never hit the blockchain, right? You leave these channel opens for like 5 years, 10 years, who knows?
Well, the idea is you say it closes next week, but then without touching the blockchain, you can push that to the next week. You can roll over with no actual transactions on the blockchain.
Yeah, and you do that by creating some commitment for 2 weeks, and within those 2 weeks, you sort of have a window to refund all your coins back as a penalty through a signed transaction. So the real implications are instant transactions sort of work now. You can buy a cup of coffee and pay for it instantly and have the funds committed within 1 second. There's no backsies. The funds are committed. You can't do this double spend thing, right? Micropayments become really, really scalable. You can send the equivalent of 1/10 of a cent. You can pay for things by the megabyte. You could pay for every single website you visit, pay 1/10 of a cent. Totally feasible under the system. Nothing hits the blockchain, why not, right? And more importantly, I think Bitcoin can really scale. If you presume that channels won't be used, everyone uses Bitcoin like we do today. If everyone in the world, 7 billion give or take, are making two Bitcoin blockchain transactions per day, you're looking at something like, at best, 24 gigabytes. It'll probably be a little bit bigger. The bandwidth use, at best, something like 50 megabits per node connection. If you have channels instead and have this channel network, and you presume everyone sort of has 2 channels for themselves, except for the core nodes, and anyone can be a core node, then those people can make a lot of transactions. They can make nearly infinite transactions inside 133 megabyte blocks, sort of in an optimal view. I think 2 channels per year, especially if you have a relative check lock time verify, is somewhat generous. Most people only have 1 or 2 bank accounts. And it's not a bank account because you don't have custodial risk. But I think 2 channels per year is a good number to use. And you're looking at something on the order of 3 megabit per second per node connection, which is very reasonable. But what you might say, like, well, 24 gigabytes isn't that bad. What happens if everyone's making 20 blockchain transactions per day, right? Then you're looking at 240 gigabyte blocks, right? That's every 10 minutes. 240 gigabytes every 10 minutes. That's not practical. I think especially if people in the future start using micropayments a lot more, I think it's very feasible for everyone in the world to be making 20 transactions per day. I think most people in the West probably do 5 to 10 per day. 20 is not that big of a jump. So you kind of want to solve that. And using this payment network, it's the same, right? If people do more transactions, I mean, unless someone gets really rich or really poor and they need to make a new channel, it's the same. So what are the storage costs under this model? You're looking at something like 7 terabytes per year with nearly unlimited transactions. And that amounts today to about $300 per year in blockchain archival storage. That's only if you want to keep a full record of every single Bitcoin blockchain transaction ever, right? For these 7 billion people, right? So if you want to, let's say, front the $300 per year, be blockchain.info or whatever, it's not that expensive. It's totally feasible. Much more feasible than, 240 gigabyte blocks. And for most people, I think those of us developers, miners, et cetera, are probably going to do the future 0.11, hopefully, pruning patch where you keep the most recent blocks. I think 2 weeks is safe. Add a 0 to that, 20 weeks or so. And the full UTXO output set. You're looking at something like 2 terabytes, right? Which is common in current generation desktops. 2 to 4 terabytes is pretty common. And will only run you about, $100, $150? And you're good forever. For those of us with cell phones, people that want to use Bitcoin, you're looking at several megabytes of storage. The SPV model gets a little bit simpler because you know the transactions that hit the blockchain that are related to you. Like if Alice wants to create a channel with Bob, they sort of both create the channel anyway. So they're only looking for transaction IDs mostly. And they can sort of ignore the old data, really. They don't really need to keep track of older outputs and older block headers. And that's the presentation. Any questions?
So in terms of functionality that you need in your transactions here, is it the usual smart transaction stuff, which is basically dependent on multi-signature hash pre-image?
Yes.
And on transactions, time lock verify?
Yeah.
Okay.
So
We're talking about this relative time lock verify. Is that on UTXOs or transactions or both? Like, what is that?
okay,
It doesn't
so that's
exist
a
yet.
two-part question. Yes. That's a two-part question is, are you using multi-sig plus hash encumbered? And yes, this is the hash encumbered part for this output. So when it is spent, it has a multi-sig signature between Alice and Bob. Ooh. So it's presumed that this output is pre-signed by both parties, except for knowing R. So they know the output. And I'm sorry, what was your second question?
The second question was the relative check lock time, and that's not an opcode that exists. That's an opcode that we would kind of like, but who knows if it'll happen. And the basic way it works is, instead of just check lock time verify, which either keeps going on the stack or fails, it will sort of return a depth in the blockchain. And you could probably do something like, return the depth of my input. If it's less than 200, fail the whole thing. If it's greater, and it's 300, 400, just push that number onto the stack. That way it's not as dangerous for reorgs. But what that lets you do is have sort of a window of time during which things can be valid.
Is that a UTXO feature or a transaction?
That is
that
an
would-
actual script output.
Yeah, that would need to be an opcode, and it does not exist. And may
No.
never, but we'll see. Oh, yeah.
So what are the usability challenges you envision with Lightning, and how much of this is obscured
Oh,
Oh, the
user
question is
wouldn't
usability, and I think the end user doesn't need to know any of this, right? The end user, the usability difference is that you're not really sending to Bitcoin addresses, and you sort of need a direct connection between the sender and the recipient.
know. Well, the internet.
The
right?
internet, yeah.
You need some kind of giant chat network / DHT or something so that everyone can talk to each other. But that exists
Yeah.
to some extent. So.
But in terms of the usability, I think it won't look too different than Bitcoin wallets today, especially if you use something like the payment protocol. If you use a payment protocol, you're sending to some domain name or URI or whatever, and you say, whatever.com, coinbase.com/username. So you type in coinbase.com/username and then hit send. You could also do something more elaborate and cryptographically secure by using, pub keys instead, but irrespective of that, you sort of need some endpoint connection.
Cool.
What's the incentive for Bob? Does he get some float or what? What's the incentive?
Yeah, so Bob can charge a really small fee. Bob can hypothetically charge, 1 Satoshi, 10 Satoshi, 100 Satoshi. It doesn't matter, right? Alice can have multiple connections to multiple Bobs, and Alice can find the rate that suits her best. And what's interesting about this is Bob's fee can be assigned integer. You can have positive and negatives. There could be situations where Bob really wants to clear up a channel in one direction because he gets a lot of fees through this direction, and it fills up. This channel fills up in one direction. So maybe someone else sends a really large transaction in the other direction, and now it's free for more spends. So it needs to be assigned integer.
I think the other thing that Bob gets, and my thinking is that Bob gets the graph, right? So the reason Amex makes more money per user than Visa is they know everything. So so the blockchain becomes very opaque under this model, and that you only see maybe 2 transactions per year per user, and they're actually doing thousands, and you just never see it. So Bob gets visibility into some subset of all the transactions that are going on, and maybe that's something he sells to marketers. I don't know what he's going to try.
But it's better today where everyone gets visibility for everything.
Yeah. Well, it's better. Yeah, because right now every transaction's open. In this model, Bob sort of gets to see more of the transactions than the other guys. So he might want to do it for free because he gets that kind of metadata.
Can you configure it in some way that the chain of hubs provides anonymity?
Yeah, as long as one of Bob and Carol decide to rip up their records, no one has to know what happened.
Can you chain them up and they can't individually be used together?
There's a lot of things you could do, but
Probably, yeah. I mean, if you trust Carol to rip up the logs, then it's easy. If without trusting the intermediaries if everyone reports everything, then there's not a lot you can do. There's probably ways to mitigate that, though.
Was there any implementation of this?
no. You need the SigHash software. That's the problem.
Yeah, none of it works with malleability.
Yeah. But seems plausible. You need to fix malleability. I think it's the best way to fix malleability. So
It probably will get fixed pretty soon. I mean, from all the people I've talked to, no one disagrees that yeah, we should have different SigHash type. And some people think it should be made default. No, most people thought it should be made default that we talked to.
yeah, I mean, all the devs seem okay with it because Bitcoin scripting multi-sig is fundamentally broken right now. Everyone's like, oh, Bitcoin 2.0, smart contracts. You can't use a lot of that stuff today because you need to fund something
doesn't
before
exist.
writing the contract, right? It's sort of weird right now. You sort of have to, without any trusted third party, both fund a transaction before you can create an output spend from it. So, yeah, chained multi, yeah. The presumption for something like this is you need something like a 3-deep chain, and for that, you need to fix malleability.
So I'm the founder of ChangeTip, and interesting background and history for everybody. We actually started off-chain or on-chain with all of our transactions, and then saw a lot of pain points that you guys highlighted here. The tips weren't free, tips weren't instant, and the total scalability of the platform was in question. So we moved to off-chain transactions so that we could address this. I'd love to move back on-chain if we could. So I feel like the what's the next steps? How do we actually do something like this? Can you be a little more crisp on what we need to do next in order to make what we
You need a
Yes.
message
So
passing
the,
protocol.
the question was ChangeTip's CEO
How do we
mentioned
make
that
this?
before everything was on chain, and and now everything has a custodial model simply due to scalability and practicality concerns because micropayments are not that feasible. Like, is that a correct summation? And the question is, what are sort of the next steps in order to get something like this
We need a
going?
message passing protocol. We need some kind of secure
There's
identity.
talks.
We need, client software. I mean, there's a lot of stuff to do that people are working on, and it's going to have to come together. We need to have a standards body to make RFCs or something like that. Yeah.
No, I mean, like, the problem is even if you wanted to implement this today, you
won't
need
work.
a soft fork in Bitcoin. I mean, you could build a trusted model, right? A trusted model with a single Bob, with a single rich Bob, can kind of work if you trust Bob.
And you make little payments, and the worst
Yeah.
you can do is take that single value. And
So that works
so you
today.
can start today and have these workarounds and stuff, and then hope that there's a fix for the malleability to really scale out, which is probably okay because right now you don't really need this, right? I mean,
You need it for micropayments.
yeah, but even for Bitcoin, not a lot of people are using it. The fees is like what, 2 cents, maybe less. So it's not a critical need right now. We can probably still scale up use of Bitcoin by a
time.
factor of quite a bit
Yeah.
before we start really needing to push things off chain.
but-
So it's not like a disaster. We have some time to work on it, but yeah, we're working on it. We should. I've talked to Richard and stuff, so I think we're sort of on the same page in how to go forward with this.
But it's sort of the devs need to be okay with it. The miners need to be okay with it because this is a soft fork, and the miners need to do it. But I think everyone's sort of okay with it.
So just as a follow-up, sorry for interrupting. If we decided that we were going to do this in a trusted model today, does
Uh-huh.
the technology support it? And
Yeah,
if
you
Yeah.
could do
we
it.
do it in an untrusted way, you're saying it requires a soft fork.
Yeah,
Yeah,
could be
you can
Bob,
do this.
and then
Yeah.
have micropayment channels from all your users, with like.
They just send Bob money, and Bob just sends someone else money. It's
No,
pretty
but
straightforward.
you can have channels to Bob,
Yeah.
and then you do these tiny little payments so that the trust is minimized, so that the most Bob can rip you off for is, a little bit. kind
Bob
of.
also doesn't only need to receive money. Bob also needs to have
Yeah,
some money
Bob needs
going
to have a
out.
bunch of Bitcoin because
And
otherwise he can't forward things to other users.
That output today can be mutated with some minor changes in 0.10. I think maybe that can be mitigated mostly. But Bob's outputs to Alice, let's say Bob encumbers his 1 Bitcoin to Alice. That part can be mutated and create some hostage scenario, but maybe in a couple months that'll solve itself.
Why can't Bob's payments to Carol, or payments from Alice to Carol, be very, very, very small, like much smaller?
Yeah, you could do
They
that.
can,
That's
yeah.
how you would get it working today. So the question is, why can't Alice's payments to Carol's be very small? And that's sort of how a trusted system would work. You don't want to trust Bob to a lot of money in transit. So you say, okay, I'll only send Bob 10 Satoshis or something. And Bob will send Carol 10 Satoshis.
And since it doesn't touch the blockchain, you can keep doing it. You send 10, 10 got there, okay, send another 10. And it's mainly like, latency and sort of
If you're
bandwidth
patient.
overhead. It'd be nicer if you didn't have any risk, and so you could send arbitrary amounts through this channel. So,
So Bob, isn't Bob, because I guess my thinking is you're saying Bob needs a lot of money,
yeah.
but
Bob needs a lot of money, even with tiny little bits going through, because I guess the idea is, let's say Alice puts a Bitcoin into this channel, and Carol puts a Bitcoin into this channel. Now Alice wants to pay Carol. She can't, because it's Carol's money in this channel. So Bob can't really credibly push it back to Carol. If all the leaf nodes or whatever, spoke nodes or whatever, if all the people surrounding Bob have put their money into the channels, no one can pay each other. They can only pay Bob. So Bob needs to front, an easy model would be, okay, Carol puts 1 Bitcoin into the channel, and Bob also puts a Bitcoin in the channel. That way it can push either way. And so Bob needs to have quite a bit of capital in order to make this system run smoothly.
For something like ChangeTip, I think it's fine,
Yeah.
because it's
Not that big anyway.
micropayments. But for larger amounts, it will probably not work.
It'll
And the
get expensive.
advantage of multi-hop is that Bob doesn't have to be rich, right? If there's Bob, Carol, and then Dave and whatever, if there's like hundreds in the middle,
As long as it sort of averages out, you're
they don't have to be rich.
Yeah.
What's your average and worst case for how many hops there would be in a practical?
Oh, so we disagree. Okay, so the question was how many hops? I think 2 intermediaries, so the 3 hops. I think that like takes over the world, right? Because like, how many intermediary payment processes do you need? I would say it's going to be a fully connected graph between all the Bobs and Carols. Even if you have 1,000 of them, that's what, 1 million different channels. That's not that many. I think that's enough. But you want 5?
I want it if it's more disconnected. I kind of want if
Okay.
there's 3 in the middle, right? But it's sort of not your choice. I think Bob and Carol do have money committed online, right? This is all hot wallets for Bob and Carol.
it's
So there's one entity doesn't want to expose themselves too much, but if they're comfortable with it, yeah, go ahead.
Yeah. And this is the security problems that like existing financial companies have now, where I've got a bunch of valuable stuff, it's online, I don't want to get hacked, and I've got all my customers depending on me to stay online and stay operational. So those are going to be the real, questions for Bob and Carol.
But for Alice and Dave, they're offline most of the time. They can encumber everything in a multi-sig, which requires some other party to sign off on it. It can be a really, really
It pushes a lot of the risk into the center.
Yeah, which is good because they're making fees off of it, and your fees are. It's interesting with commodity money, right? With commodity money, your fees paid in the form of your risk paid in the form of fees is effectively what the main focus is on, but with fiat, because it's debt-based, it's primarily with counterparty risk. So your interest rate is primarily paid based on your counterparty risk. Whereas with commodity money, like with gold, it's you're taking on the security risk. So the fees are based on security risk. So people that are more secure probably will charge lower fees.
So when taking into account the latency inheritance system, do you make any estimates of the capital ratio of the individual hubs to the throughput? What it might be?
Sorry.
So the question was like how much capital Bob and Carol have to have, and how that relates to the throughput through the system. We haven't really. They need a bunch
it'll
of money.
solve itself, right?
They
They just charge fees.
Right now, the time value of Bitcoin is sort of 0.
Yeah.
So like, there's a lot of people who have like, oh, I've got 20,000 Bitcoins I got from the U.S. Marshals, and what am I going to do with it? So you can put it up here and extend things. Okay.
This is a Bitcoin lease rate with no counterparty risk, right?
Last question. Okay, so the last question.
Do you think that this could harm the security of the blockchain if enough people were doing these off-blockchain transactions that miners backed down because there weren't enough fees in the future when the reward is lower?
I don't think so at all.
I think the blockchain on blockchain is so much easier that the first thing you do is you fill up the blocks, and you move to this kind of thing when the fees become prohibitive for small transactions. So if the blocks are empty and there's miners are going hungry, why bother with all this complicated stuff? Just send people Bitcoins directly. So I don't think it's a big risk.
Yeah, I mean, there's interesting ways to do, increasing the block size and
Yeah,
things
if
like
miners
that.
really get mad and they get together, they prevent some of this stuff from happening.
I think miners are okay, right? They're going to get fees no matter what. I think they're going to restrict the block size such that they maximize their fees. And you want to do that in a constructive way, and I don't see why miners would be against it. I think the blockchain transaction fees will probably go up substantially, though, right? If you're dumping data onto the blockchain because you think Bitcoin transactions are going to stay cheap, I don't think it will. I think it can go up like $1 plus, $10, who knows, per Bitcoin transaction. But that's fine because you just leave these channels open for years on end.
Okay.
All right?
Got it?
Okay.
Thanks.
Thank you.